Hello everyone, welcome back to the course Financial Mathematics for Actuaries. In this session, we are going to learn the topics related to yield curves and the term structure of interest rate. Specifically, we are going to learn why do bonds with different maturities have different interest rates, what are the stylized facts about the term structure of interest rates, and what are the economic theory that tries to explain these stylized facts. Okay, so what is the term structure of interest rate? So bond with identical risk, liquidity and tax characteristic may have different interest rates. Okay, because the time remaining to maturity is also different. So even if, okay, the bond with identical risk, liquidity and tax characteristic may have different interest rate because the time to maturity is different. In practice, therefore, bonds with different maturities and risk features are offered. Okay. The relationship between the short term and the long term interest rate is basically known as the term structure of interest rate. So, technically defining, the term structure of interest rate is just the relationship among the interest rate of bond that are otherwise similar but that have different maturities. Okay, so the relationship between the short term bonds and the long term bond, or the yield of short term bond and the yield of long term bond, are basically known as the term structure of interest rate, or the simply term structure. Okay, now let us understand what is the yield curve. What we mean by the yield? We have already understood how to compute the bond yield. Okay, but what is the yield curve? Of course, the yield curve is when you compute the yield of the bonds and put it in the graph, we will get a curve, okay, in the x and y space. Okay, so a plot of the yield on the bond with different term to maturity but the same risk, liquidity and tax consideration is known as the yield curve. Okay, so it describes the term structure of interest rate for a particular type of bond, right? And here we will consider a particular type of bond which is free from like the risk. Okay, so it is easiest to hold these characteristic constants for the treasury bond. Okay, so the risk structure, the liquidity structure and the tax consideration more or less similar for the treasury bond, and therefore it is always better to understand the yield curve by considering the treasury bonds. Okay, so a common way to analyze the term structure is by looking at the treasury yield curve or government bond yield curve. However, okay, for your curiosity, note that the treasury bond with maturity of 1 year or less than 1 year is commonly known as the treasury bills, and the treasury bond, okay, that are mature within the 2 year and 10 year are basically known as notes. Okay, and the government bond or the debt instrument which is mature, okay, or the maturity period is more than 10 years are basically known as bonds. Okay, however, okay, let us understand all these things, okay, together, and we will simply call it as government bond. Okay, so for simplicity we often refer to all these securities as bond, but you must understand that what is bills, what is notes and what is bonds. Okay, but in our case here we will consider all of them are bonds and then we will proceed, right? Okay, so now let us understand the upward sloping okay, yield curve and the flat yield curve and downward sloping yield curve. Okay, so what is the upward sloping yield curve, also known as the normal yield curve? Okay, when yield curve slope upward, this is okay, when yield curve slope upward, the long term interest rates are usually higher than the short term interest rate. Okay, or you can say that when the long term interest rates are higher than the short term interest rate, then the yield curve should be a normal yield curve or a upward sloping yield curve. This is what here. Okay, this is the this black one. Okay, right. What is flat yield curve? In case of flat yield curve, okay, the short term interest rates and the long term interest rates are same. Okay, when yield curves are flat, the short term and the long term rates are similar. Okay, same, and therefore we will have this curve. Okay, flat yield curve, this one. Okay, on the other hand, the yield curve will be downward sloping, or it will call inverted yield curve, this one. Okay, in which case the long term rates are generally lower than the short term rates. Okay, when the yield curves are inverted, the long term rates are below the short term rates. Okay, so we have upward sloping yield curve, we have flat yield curve, we have inverted yield curve. But most of the time we will observe this normal yield curve or the upward sloping yield curve, and also therefore it is considered as a normal yield curve, in which case the long term interest rates are usually higher than the short term interest rate. Now what is the like facts about the term structure? Okay, or let us also understand what we mean by term structure facts, in which case let us understand the stylized facts about the term structure of interest rate. Remember, we are naming here stylized fact, meaning that the facts are not the actual facts, but these are data driven, okay, data based, in which case you can disprove also sometime, but like these are the facts that are based on the empirical observations. Okay, like several previous studies have actually observed the yield curve and they look like a typical pattern. Okay, like this, right? So we will list it 1, 2 and 3. There are 3 stylized fact about term structure. Okay, the first one is interest rate on bonds of different maturities move together over time. Okay, interest rates on bond of different maturities move together over time, meaning that short term interest rates and long term interest rates will move together. Whenever short term interest rate increases, long term interest rate also will increase. Whenever short term interest rate decreases, the long term interest rate will also decrease, right? And the second one simply saying that the yield on short term bond is more volatile than the yield on long term bond. This one I have put it to like simple way to like remember it, but like you can also understand in this way that when short term interest rates are low, yield curve are more likely to have an upward slope. Okay, and when the short term interest rates are high, yield curve are more likely to slope downward and be inverted. Okay, and the third stylized fact says that yield curves usually slopes upward. Okay, so these are the stylized fact. We have listed it 1, 2, 3 accordingly. However, we can place it anywhere. Okay, but when explaining it, okay, you will say like fact 1, fact 2, fact 3. Be careful that which fact you are actually referring to. Okay, but for our region here, under fact 1 we are like referring to interest rate on bonds of different maturities move together over time. Okay, fact 2 says that when short term interest rates are low, yield curves are more likely to have an upward slopes, and when short term interest rates are high, yield curves are more likely to slopes downward and be inverted. Okay, and the third, okay, we will list as yield curve usually slopes upward, right? Okay. So, what is the reason of these three facts or this type of behavior? Why interest rate or why the yield curve actually behave in such way? Okay, there are huge debate in economics. There are some theories that came forward to explain these facts. Okay, one of such theory is that the expectation theory, and also the second one is the segmented market theories, and the third one is liquidity preferred or liquidity premium theory. There are also one more theory that is known as the preferred habitat theory. The conclusion of preferred habitat theory is just equivalent with the liquidity premium theory, and therefore once you understand the liquidity premium theory, you can also understand the preferred habitat theory. So let us understand this theory one by one. The expectation theory tries to explain fact 1 and 2, but it could not explain the fact number 3 in our list. Okay, the segmented market theory could explain the fact 3, but it could not explain the fact number 1 and fact number 2. However, the liquidity premium theory could successfully explain all this. Okay, to understand both this theory, it is very important to understand the expectation theory, which takes the common sense logic. Okay, and therefore let us start with the expectation theory. Okay, it makes the common sense proposition. What is the common sense proposition here? The interest rate on a long term bond will equal an average of short term interest rate that people will expect to occur over the life of the long term bond. So, it says that the long term bonds are just the average of all these short term interest rate what people expect. Okay. So, for example, if people expect that short-term interest rate will be 10% on average over the coming 5 years. The expectation theory predicts that the interest rate on bond with 5 year to maturity will be 10% too. Okay, and if short-term interest rate expected to rise even higher even after this 5 year period, so that the average short-term interest rates over the coming 20 year is 11%, then the interest rate on a 20-year bond would equal the 11% as well, and would be higher than the interest rate on 5 year bond. Okay. So, let us understand this expectation theory. To understand this, we must understand the assumptions the expectation theory take. What is the assumptions? Bonds of different maturities are of perfect substitutability, right? What do you mean by this perfect substitutability? We will understand it slowly, but buyer do not prefer bonds of one maturity over other. So, this theory assumes that a typical buyer will not prefer bonds of one maturity over other maturity. So, they will not hold any quantity of bond if its expected return is less than that of another bond with a different maturity. Okay, and therefore bonds that have these characteristics are said to be perfect substitute. Okay. So, perfect substitutability means that, okay, at a given point in time, people want to hold two types of bond of different maturity only if the expected return of these bonds are equal. Okay. So, if bonds with different maturities are perfect substitute, the expected return on these bond must be equal, right? So, let us consider the following investment strategies. Okay. Strategy 1 says that purchase a 1 year bond, and when it matures in 1 year, purchase another 1 year bond. So, here we will consider that this 1 year bond is a short term bond. Okay, meaning that you are now initially you are trying to invest in or planning to invest in this short term bond, okay, and when it matures in 1 year, purchase another short term bond, okay. The strategy number 2 says that purchase a 2-year bond and hold it until the maturity, in which case here we will assume that this 2-year bond is a long term bond, okay, while 1-year bond is this short term bond. We will consider here that the 2-year bond is the long term bond, okay. So both strategy must have the same expected return, right? Whether you will consider the strategy number 1 or strategy number 2, according to expectation theory, okay, both strategy must have the same expected return. If people are holding both 1-year and 2-year bond, the interest rate on the 2-year bond must equal the average of the 1-year interest rate. Okay, for example, let's say that the current interest rate on the 1-year bond is 9% and you expect the interest rate on the 1-year bond next year to be 11%. Okay, if you pursue your first strategy of buying the 1-year bonds, okay, the expected return over the 2-year will be just average out to be 10% per year, that is 9 plus 11 divided by 2, okay. So you will be willing to hold both the 1-year and 2-year bonds only if the expected return per year of the 2-year bond equal this 10%, okay. So only if the two type of bond will give you the similar expected or same expected return, you will be likely to hold both bond, or like indifferent of holding this bond. Otherwise, what will happen? You will be choosing one bond which will give you a highest expected return. More generally, for an investment of $1, consider the choice of holding for 2 periods a 2-period bond, okay, that is the long term bond, or 2 1-period bonds, that is the short term bond. And also let us denote that IT is today's interest rate on a 1-period bond, okay, or 1-year bond, and IT plus 1E is the interest rate on 1-year bond expected for the next period. Meaning that if you are purchasing a bond which will give you IT interest rate, and if you are holding it till next year, then you are predicting that next year this bond will give you this much interest rate, okay, right, okay. Again, like I to T is equal to today's interest rate on 2-year bond, right. So this interest rate for us is like long term interest rate, whereas this interest rate is the short term interest rate, and this is the short term interest rate expected in the next period, okay. So from the investment strategy 1, the expected return can be computed as that is 1 plus the interest rate multiplied by 1 plus the expected interest rate in next to next year minus 1, okay. This is how we will compute the expected return, okay. This is the same way what we have already understood, okay. So don't have to be worried about, okay. And now open this up and we will get 1 plus IT plus IT plus 1 E plus IT time IT plus 1 E minus 1. So this 1 and this 1 will therefore get cancel, and we will have IT plus IT plus 1 E plus IT multiplied by IT plus 1 E, this one. Now look at this here. For a like smaller value of IT and IT plus 1 E, the product of these two will be very small or extremely small. For example, here we will see that, okay, if IT is equal to 10% and also IT plus 1 E is also equal to 10%, then their product will be like only 0.01, right? And therefore we can ignore this, right? Ignoring this, we will rewrite this as it plus it plus 1 e, right? Now, if you are taking the second strategy, then what will happen? From the investment strategy 2, the expected return can be computed using the similar formula here, okay, is that 1 plus I2t multiplied by 1 plus I2t minus 1 is equal to again 1 plus 2I2t plus I2t square minus 1. Again this one and this one will get cancelled, okay, and therefore we will simply have 2I2t plus I2t square, right. Again you will see that for a small value of I2t, for example similarly, okay, like if I2t is equal to like 10%, then I2t multiplied by I2t will be very small or extremely small, and therefore this term can be ignored, right, and we will have only 2I2t. Now both the bond will be held only if, okay, the expected return of strategy 1 and expected return from strategy 2 will be equal, right, and therefore this it plus it plus 1 e must be equal to 2I 2t here, okay. So it plus it plus 1 e is equal to 2I 2t. Upon solving for this I to t, that is the long term interest rate, which will be it plus it plus 1 e divided by 2. So what is this? Basically this is just the mean value, yes or no, or the average value, right. So this is the same 2-year bond, or the interest rate for 2-year bond is just the equivalent, just equal to the average of 2 1-year bond, okay, right. So here for n period we can go on computing similarly, and we will get that int is equal to it plus it plus 1 e plus I t plus 2 e, and we will go up to I t plus n minus 1 whole divided by n, okay. So this simply says that, okay, the n period interest rate equals the average of the 1 period interest rate expected to occur over the n period life of the bond, okay. Let us understand this, putting some numerical value into it. It will be very clear then, okay. A simple numerical example might clarify what the expectation theory is saying, okay. If the 1-year interest rate over the next 5 years is expected to be 5%, 6%, 7%, 8% and 9%, the equation what we have just seen indicate that the interest rate on the 2-year bond would be, okay, 5.5%, okay, and while the 5-year bond, okay, the interest rate for the 5-year bond would be 7%. This is the average, okay, of 7%. Similarly you can compute it for like 3-year or like 3rd year, 4th year, right. So doing a similar calculation for 1, 3 and 4th year, okay, interest rate, you should be able to verify that the 1 to 5 year interest rates are what? 5%, 5.5%, 6%, 6.5% and 7% respectively, okay. Therefore we see that the rising trend in expected short term interest rate produce an upward sloping yield curve, okay, along which interest rate rise as maturity lengthens, okay. So here you can see that as the interest rate increase 5, 6, 7, 8, okay, increasing trend, okay, here as like the number of period increase from 1 to 2, 3, 4, 5, and the interest rate is also increase for 1-year period bond. Now you can also calculate the long term bond which is also increasing pattern. So what does this means? This means that it could successfully explain our fact 1, which says if the short-term interest rates are increased today, they will tend to be higher in the future. Okay, hence a rise in the short-term rate will raise people's expectation of future short-term rates. Because long-term rates are the average of expected future short-term rates, a rise in the short-term rates will also raise the long-term rate, causing both short-term and long-term rate move together, which explain the fact number 1. So, expectation theory could explain the stylized fact 1. Now, whether it could explain the stylized fact 2? Yes, it could also explain the stylized fact 2. What it says, when short term rates are low, people generally expect them to rise to some normal level, okay, in the future, and the average of future expected short term rates is high relative to the current short term rate. Therefore, long term interest rate will be substantially above the current short term rates, and the yield curve would then have an upward slope, right? Conversely, if short term rates are high, okay, people usually expect them to come back down, okay, after some period of time, okay, because it is already high, okay, people expect that it will come back down, okay. So, long term rate would then drop below short term rate because the expected or the average of expected future short term rates would be below current short term rates, and the yield curve would slope downward and become inverted. So, this theory or the expectation theory could also explain the fact 2. What about fact 3? It cannot explain the fact 3, which says that yield curve usually slopes upward. Okay, like the typical upward slope of yield curve implies that short term interest rates are usually expected to rise in the future. So, every time this short term interest rate is going to increase, right? So, in practice, short term interest rates are just as likely to fall as they to rise, right? And so, the expectation theory suggests that the typical yield curve should be flat rather than upward sloping. So, it could not able to explain why the yield curve should upward slope. Okay. So, what is the takeaway here? The takeaway is, okay, bonds of different maturity have perfect substitutability. That is the assumption under which expectation theory works. The term structure of interest rate reflects financial market belief about the interest rate. So, expectation theory basically considered what the financial market believe, or how investors typically like see, right? So, the long term interest rates equal the average of all short term interest rate expected to occur over the life of the bond according to the expectation theory. Okay. So, while this theory successfully explained the fact number 1 and fact number 2 in our case here, it could not able to explain fact number 3. So, what is the shortcoming of this expectation theory, or the what is the criticism of this expectation theory? The expectation theory explains an upward sloping yield curve as being the result of investors' expectation, okay, of future short term rates, that is to be higher than the current short term rate, okay. But if the yield curve is typically upward sloping, investors must be expecting short term rate to rise most of the time. So, this explanation seems unlikely because at time any particular time short term rates are about as likely to fall as to rise, right? So, we can conclude that the expectation theory is overlooking something very important about the behavior of the investor in the bond market. Probably it fails to account for the time varying risk premium. Theory gives us important like lesson that, or important message that says This theory is based on what the financial market commonly believe. Okay, it says that when people expect that the short term interest rate increases, okay, over the few years, then the long term interest rate should also increase. When people expect that if the short term or the current short term interest rates will decrease in the near future, then the long term interest rates also should decrease. Okay, but this theory fails to account for any time bearing risk premium into account. Okay, there are also some theory which tries to explain the stylized fact, which we are going to discuss in the next session. Okay, for today we will stop here. See you in the next session.